that was close. As you know, brakes are the most important safety feature of any car on the road. Every system on a car is concerned with getting the car moving except the brakes. Stopping the car is the sole responsibility of the braking system. In this program, we're going to talk a little bit about braking systems and how they work. And then we'll cover safety issues and tools in brake repair, the various types of brakes, how to bleed, flush, and pressure test braking systems, how to decide what parts of the braking system need repair, and what you need to know to perform basic repairs on braking systems. Braking systems create an incredible stopping force that's 10 times more powerful than the force putting the car in motion. To do this, brake systems use 3 different methods to slow the speed of the car: leverage, hydraulic pressure, and friction. First, leverage is used in the form of the brake pedal. Leverage multiplies the mechanical pressure or force of your leg several times before passing it on to the hydraulic system. The leverage from the foot pedal is converted to hydraulic pressure by the master brake cylinder. The hydraulic system uses the pressure of fluid for power. The master cylinder has a reservoir of brake fluid and 1 or more pistons. The leverage force from the foot pedal moves the piston in the master cylinder, which in turn compresses the brake fluid to create hydraulic pressure. This hydraulic pressure is then sent to each wheel through the brake lines. The third force involved in braking systems is friction. This is where the rubber meets the road, as they say. Friction is the amount of resistance encountered when one object is moved in contact with another, or in other words, how hard it is to slide one object across another. There are 2 ways friction is involved in braking systems: when brake pads or shoes are pressed against a brake disc or drum, and when a moving vehicle's tires contact the road. As the master cylinder sends hydraulic pressure to each wheel, the pressure pushes the brake pads or shoes against the brake discs or drums. This creates friction to stop the car. Of course, the friction of tires on the road is applied at the same time. The point is, the brake system allows a 90-pound person to stop a 5,000-pound vehicle simply by pressing down on the brake pedal. It's pretty amazing. Now that you know a little about the basics of a brake system, let's take a look at its components. A typical automobile has disc brakes in front and drum brakes in the rear, although some have disc brakes both front and rear. The brake system is controlled by the master brake cylinder that's directly connected to the brake foot pedal. The master brake cylinder is the primary component for pressurizing fluid in a hydraulic system. It has a reservoir for holding brake fluid and is activated each time the driver depresses the brake pedal. In addition to the master cylinder, a braking system consists of brake lines, brake hoses, individual wheel cylinders, drums, rotors and calipers, pads and linings, shoes, and control valves that regulate the flow of the hydraulic fluid. Brake lines and hoses conduct brake fluid from the master cylinder to the wheel cylinders at each wheel. Brake lines are seamless steel tubes. Brake hoses are flexible nylon or rubber hoses. Control valves ensure that the rear brakes are always activated before the front brakes, and they balance the braking force at each wheel. In drum brakes, the brake shoes are located inside the brake drum and press out against it. As the shoe presses against the drum, it creates friction to slow or stop the drum's momentum. Because the drum is directly connected to the wheel, the action is transferred to the wheel of the vehicle. When the brakes are released, a spring mechanism resets the shoes. In a disc brake system, discs, also called rotors, rather than drums, are directly attached to the wheels. A caliper straddles the disc and holds the disc pads. When a driver steps on the brakes, hydraulic pressure is delivered to the caliper, which translates that force into mechanical energy to press the brake pads against both sides of the disc and slow or stop the vehicle. For safety reasons, anti-lock braking systems, or ABS, are becoming the most common type of brakes in modern cars. ABS brakes use the same parts and principles of leverage and hydraulics as brakes, but have electronic compensation features that older braking systems don't have. During hard braking, this electronic compensation feature prevents the wheels from locking up regardless of the surface. It does so by acting as if you were tapping the brakes a number of times per second. And ABS systems automatically adjust brake pressure at each wheel according to speed. This feature of ABS prevents drivers from losing control of their vehicles when hard braking or when braking on slippery roads. Virtually all new vehicles employ power-assisted brakes. Power-assisted or power brakes lessen the amount of force you have to apply to the brake pedal. They also reduce the distance your foot has to travel to engage the brakes. The most common type is vacuum-assisted. The vacuum diaphragm is located between the brake pedal and the master cylinder. Now that you know a little about the brake system and its components, let's talk about the tools needed for basic repair. In addition to common shop hand tools, compressors, and lifts, there are a few tools specific to brake work. A brake pad spreader, a caliper piston depressor, brake spring tools for return and hold down springs, a caliper dust boot installer, a seal puller, a brake adjusting spoon, a brake cylinder hone, a bleeder screw wrench. Some of these tools are more critical than others, depending on the type of repair you're doing and the type of brake system you're working on. Always make sure you have the right tools to do the job safely and correctly. In brake repair, as with any other auto repair work, your personal safety is important. So be sure to wear the proper protective equipment for the job you're doing and follow all shop safety procedures. Here are some specific requirements for brake repair. Always wear safety goggles when disconnecting brake lines, hammering, chiseling, or prying. Before working on brakes, make sure the vehicle's airbag or air suspension systems have been disabled. Follow all shop procedures when lifting a vehicle. Then be sure the vehicle is properly supported on jack stands or a hoist before beginning brake repair work. Don't use compressed air to clean brake components. Brake dust may contain asbestos, which may be hazardous to your health. To prevent the brake dust from becoming airborne while disassembling brake systems, wash them down with a brake wash system or use an aerosol brake wash. Use caution when handling brake fluid. Don't let it come in contact with painted surfaces and be sure you don't get it in your eyes. Wash your hands thoroughly after handling brake fluid. Follow proper hazardous material guidelines when disposing of contaminated brake fluid. Before you can do any work on the brake system of a vehicle, you need to find out the extent of the damage and assess what repairs are needed. After lifting and supporting the vehicle, remove the tires to do a complete inspection. Start by checking the brake lines for cuts, bends, or kinks, especially around the steering components. Ideally, lines should be rust-free, but a light coating of rust is okay. Hoses should be flexible without cracks, and look for damage from road debris. Then check each wheel for damaged rotors or drums. Check the backing plates to make sure they don't interfere with the drums. Look for unusual amounts of moisture around the brakes. This could indicate leaking brake lines or rubber seals. Check for damage to the calipers and mounting areas. Look especially for extensive amounts of rust or damaged springs. Inspect the caliper for fluid leaks, torn dust boots, or missing parts. Rebuild or replace any parts as necessary. Check the pads for alignment and wear. On most vehicles with disc brakes, pad wear can be checked by peering through the hole at the top or side of the caliper. If the pads need replacing, chances are the rotor may need work as well. Inspect rotors for non-machine grooves, heat stress cracks, minimum wear thickness, glazing, a brake lining that's been overheated and become smooth or glossy, and disc runout, side-to-side warping of the brake disc friction surfaces. The rotor can be checked for disc runout by using a dial gauge. On drum brakes, you'll have to remove the drums and inspect the shoes. If they're worn too thin, they need to be replaced. Drums are usually stamped with a wear indicator that shows the maximum wear diameter. To finish the inspection, look for damage to the wheel cylinder. Make sure the cup fits securely and doesn't leak. Also, check for any broken springs. Check the master cylinder for leaks. Finally, check the dash lamp operation if the vehicle is equipped with ABS. The ABS system light will come on automatically when the ignition is turned on. It'll perform a self-check and go off if the ABS system checks out. It'll remain lit if something's wrong. The parking or emergency brake uses a cable with direct force instead of a hydraulic system like the regular brakes. This gives vehicles a backup braking system in case the hydraulic system fails. On most vehicles, parking brakes work on the rear wheels, engaging the brake shoes. When the parking brake is released, a spring on the shoe returns it to its normal position. Some parking brakes are self-adjusting, but you need to adjust those that aren't. Release the parking brake and safely raise and support the vehicle. Adjust the rear brakes by loosening the adjusting nut until there's slack in all the cables. Rotate the rear wheels and tighten the adjusting nut until there's a slight drag at the wheels. Loosen the nut until all drag is eliminated. Apply and release the parking brake several times. Make sure there's no drag on the wheels. One of the most common brake repairs you'll do is repairing brake lines. To service cut, kinked, or bent brake lines, replace them with new lines from the original equipment manufacturer. Do not use copper or aluminum tubing or rubber hoses. Do not attempt to repair brake lines or hoses. Don't use compression fittings. Route the brake lines in the same locations as they were from the factory. Reinstall all supporting clamps and springs that were removed during repair. Once you're done repairing the brake lines, you need to add brake fluid. Brake fluid absorbs moisture, so make sure you don't leave the container open to the atmosphere. Be sure to use the right type of brake fluid. Most vehicles will use .3, 4, or 5. Check the master cylinder for a label that'll tell you the correct type for the car you're working on. Don't try to reuse fluid drained from the system. It might have contaminants that could damage it. Bleeding is done to remove air from the brake fluid. Air inhibits the proper functioning of a hydraulic system. Bleed one wheel at a time. Bleeding often starts with the wheel furthest from the master cylinder, but follow the manufacturer's guidelines to decide what order to bleed each wheel. To begin, clean the bleeder screw. Have another technician pump the brake pedal several times, then hold with moderate pressure. Slowly open the bleeder screw and allow fluid and air to flow out until the fluid runs clear. Close the bleeder screw and repeat for each wheel while making sure the master cylinder doesn't run dry. Refill the master cylinder when complete. Wheel bearings, another important part of the brake system, are located inside the hub. Most late model vehicles have sealed bearing packs which must be replaced rather than serviced. However, on vehicles where bearings are accessible and serviceable, they need periodic maintenance. To remove the bearings, first remove all outside dirt from the housing and then pry the dust cap from the hub, taking care not to damage the flange. Grasp the cotter pin and pull or pry it free from the spindle, then remove the nut. Pull the hub assembly off the spindle. Pry the inner bearing and grease seal from the hub. Clean all parts in a non-flammable solvent and let them air dry. Carefully inspect and replace parts as needed. Thoroughly pack the bearing with fresh, high-temperature wheel bearing grease before reinstalling. Make sure to follow the manufacturer's guidelines for the type of car you're working on. If the vehicle you're working on has collision damage around one of the wheels, chances are you'll have to remove the caliper assembly. There are two basic types of disc brakes, floating caliper and fixed caliper. Floating is the most common, so for purposes of this demonstration, we'll remove a floating caliper system. To begin, place a drain pan under the work area. Spray the brake pads and rotors with brake cleaner. Next, remove the caliper by loosening and removing guide pins. Now open the bleeder screw to allow brake fluid to escape. Compress the caliper with a brake pad spreader. When the piston is fully compressed, close the bleeder screw. If the caliper is going to be overhauled or replaced, loosen the brake hose, lift off the caliper, and remove the brake hose completely. If the caliper doesn't require overhaul or replacement, prepare a length of wire or strong string to support the caliper. Don't let the caliper hang from the brake hose as it could cause damage. Be sure to note the position of any clips or springs on the caliper. Now remove the caliper from the rotor and, if equipped, the mounting bracket. The brake pads may or may not come off the caliper. This is normal. If they don't come off immediately, simply tap them off with a hammer or pry them out. With the caliper removed, you can now change the brake pads and service the rotors, caliper, and brake lines if necessary. It's critical to thoroughly test your brake work before releasing the vehicle to its owner. When you're satisfied the work you performed is complete and correct, Take the vehicle for a test drive and check the following. Make sure the brakes don't grab or release too slowly, and that they don't pull to one side or make squealing, scraping, or grinding noises. Make 8 to 10 stops from about 30 miles per hour to burnish or seat the new pads when a rotor's been replaced or resurfaced. Make sure the foot pedal doesn't require excessive travel or pressure, and that the pedal doesn't have a spongy feel or vibrate. Make sure the parking brake works and releases as it should. Make sure there are no visible fluid leaks. That's all the time we have for brake repair. In this program, you've learned how a brake system works by using leverage, hydraulic pressure, and friction. Safety issues and tools used in brake repair. The types of brake systems and components. How to inspect the brake system for repairs. How to bleed, flush, and pressure test brake systems. And how to perform basic brake maintenance and repairs. Remember, the brake system is the most important safety feature on any car. Help keep vehicles safe for everyone by making sure the brake work is done right.